Hi, I thought I would talk about what I'm going to do in my project and put a little movie on it and show you what I've done so far and explain what I'm going to be doing in the future. Okay, so what I have is a partially completed R package, and it's what's called an R Commander plugin. And R Commander does the menu version of R, not the R Studio. It's independent of that. And I have something from geostatistics. And when you do geostatistics, essentially you're doing regression based on longitude and latitude rather than our usual variables as we've been doing in this class. And this is kind of interesting. So what I'm going to do, if you notice on here, you've got our basic menus, and I have a special one. The plugin, you write your own menu codes, and so I have one for geostats. And what I'm going to do is pull up a particular interesting geostat menu, and it is in the gstats package. Whoops. This is actually pronounced Moss. Let's see, scroll back up here a little bit. Okay, now once I have a data set in here, see how it shows up and it's nice and blue. When I click on that, my AutoCreate comes up, and then I can select my longitude, which I know is X, my latitude, which I know is Y, and the variable that I want to mess with happens to be zinc. And I'm going to give it a new name, because what I'm going to do, I'm going to build a model. Essentially, I'm saying zinc is a function of longitude and latitude. And I'm going to create what's called a variogram, and I'm going to get predictions. Okay? So let's see, what should we call it? My pred. I'm going to click on OK. And it's going to say I can't find it. I don't know why. And I'm going to say library. That's why it's not finished. Auto map. And then I'm going to try it again. And I'm going to swear. Swearing is optional. X, Y, and zinc. Okay. So the variogram is down here. The experimental ones are the dots. The fitted ones are the lines. And let's see if I can blow this up a little hard. There it is. Okay. So when we talk about kriging in geostats and such, the nugget is this value here, the vertical value. The sill is the value. Now my brain just went dead. All right, well, I'll remember it. It'll come back in a minute. The range is the distance when things start peaking out. When things start moving in a definite direction, it's essentially the movement stops increasing. The sill is like the distance when things the vertical distance. The partial sill is the distance between the top of the line and your nugget. Okay. And the model, the STE, is what's called a Matern model, a special case of it. And it has a parameter called kappa 1.1, Don't worry about that. The prediction, here's what it looks like. The Maas is a river basin in the Netherlands, and it looks just like this. And there's the standard error that goes along with that. And those are our prediction models. Okay, so that's fair enough. That's the spatial model. So what I'm going to do is put together the spatial temporal model. So this part's already done. The spatial temporal is going to have what we call a separable model. So I'm going to take the experimental for the spatial, then which is already done, then do the temporal, the time variable, and then construct the models and put them together, and then do prediction on the space and time, and then I'll produce Google Earth maps, and you can see the predictions change over time. That's the ultimate output, and I will put them up on a little movie that you can see. Okay? Great. Thanks.